I'm Wenli. I think you know what analysis of variance is. Analysis of variance is a hypothesis testing whether there exists difference among means of multiple groups, multiple populations. Okay? And I said there are three prerequisites for analysis of variance. One is that K groups are independent. Two, K groups follow normal distribution. Three, the K groups variances are equal. Okay, those three of them are prerequisite. Now today I'm gonna explain principles of ANOVA, introducing F distribution. F distribution is the final distribution in these lectures, in this course. Okay, it is very interesting thing, principle of ANOVA. I think it is a kind of art. Okay, let's see what is art. Principles of ANOVA. The test statistic should lead to the rejection H0. We have to know what is the test statistic for hypothesis H0, mu1 equal to mu2 equal to mu k. Okay? No difference among population means. If the sample means are far apart from each other, they are k many sample means like this, distributed like this, then each sample means is apart from another. Okay, then we have to reject H0. Otherwise, or conversely, sample means is like this, small range. Then we cannot reject H0. That saying, conversely, if their differences are not large, small, the null hypothesis should not be rejected. In other words, if the variance of the sample means is small, then H0 should not be rejected. If variance of sample means is large, H0 should be rejected. Understand that? Moreover, since the variance of sample means depends on the unit of measurement, of course, the test statistic should eliminate the unit of sample means variance. We don't like this. Test statistic has some unit. So test statistic must be unitless, right? Let's now explore two methods of estimating population variance sigma square. Remember the assumption for performing analysis of variance that the variances of K groups are equal. I show you last time there are K groups and normality, each group follows normal distribution and same equal variance sigma square. And we will obtain this kind of samples from each population. So sigma square, sigma square, sigma square, sigma square. So we have to estimate sigma square, only one value from these samples. Let's see again, come here. So there are two methods of estimating sigma square between groups variance. It is, I say, art, kind of art. We studied variance of x bar is sigma square over n, and we denoted sigma x bar square. Now I'm using y instead of x. So I'm using y bar. Variance of y bar is sigma square, 1 sigma square over n, okay? Then what is it? Sigma square equal to variance, say, sigma y bar square. We obtain this relation So sigma square equal to n times sigma y bar square. So if we estimate sigma y bar square from what? From sample means, okay? Then we denote it like this hat with the hat denoted this way. Then we obtain a estimator of sigma square that we call it between group variance estimator of sigma square. Okay, therefore, by estimating this one from K sample means denoted as sigma y bar square hat, one estimator of sigma square can be obtained. This is called estimator of between group variance. Okay? Understand that? And I said PTW sigma square hat. Okay, second, within group variance. Within group variance is real variance estimator. We studied two independent groups, okay? Difference between means of two groups. In that case, I say sigma 1 square, this one is sigma 1 square, this population sigma 2 square is equal to sigma square, same. The variances of two groups, same. So I don't need here subscript, sigma square. Then from population 1 sample X, from population 2 Y and 2, we pool them and we call it pooled estimator, right? We have to pool those two samples in one pool and estimate sigma square. Pool at that time we denoted by pooled estimator of sigma square. Same thing applied here. Within group variance refers to the variance obtained from the samples taken within each group. This is commonly referred to pooled variance. Since the variances of K groups are assumed to be equal, okay, prerequisite, the population variance sigma square can be estimated by pooling all the samples together, which is called estimator of within group variance. Okay, so y1j minus y1 bar square from samples of first population 1, and from second population samples y2j minus y2 bar squared, and so on, divided by, we assume the sample size is n. Okay, so here how many degrees of freedom? N minus 1. Here n minus 1. Here n minus 1 degrees of freedom. So the degrees of freedom of numerator is k times n minus 1. We call it within group variance estimator. Okay, sigma square within hat. Okay, then we have to eliminate the unit. Now we need to create test statistic based on the ratio of these two variance estimators. Which one should be used as denominator? Of course, between group estimator. This one is, in this case, actually sigma 제곱 hat. Okay, within group estimator is real estimator of sigma square. This is a trick. This is a what? A different kind of estimator between group estimator. Since we will reject null hypothesis H0 when the between group variance is large. This one is large, we reject. This one is large, then the value of F will be large and we reject H0. So test statistic will be this ratio of these two variances. Then eliminate the unit, okay? At this point, the unit of between group variance and the within group variance is related. So F statistic, this statistic becomes a unitless test statistic. Okay, get it? I think it is a very interesting idea and topic. Definition, F distribution. Chi-square distribution. Chi-square degrees of freedom, D1, and chi-square degrees of freedom, D2, okay? And they are two chi-square random variables are independent. They are independent. Then the ratio of two independent chi-squared random variables divided by their respective degrees of freedom follows F distribution. Complicated, right? So chi-square distribution divided by degrees of freedom, each degrees of freedom. Another chi-square distribution divided by its degrees of freedom. The ratio of these two chi-square variables, they are independent, then that it follows degrees of freedom D1, D2. The order of degrees of freedom important. You should not change D2, D1. Degrees of freedom numerator come first, and denominator degrees of freedom second degrees of freedom of F. Okay, so very complicated random variable probability distribution function. And what is the shape of F distribution? The F distribution like this. Depending upon the degrees of freedoms, small degrees of freedom like this, and degrees of freedom increases, then the skewness will be eliminated. Okay. Finally, degrees of freedom D1, D2 are very big. Then the F distribution comes to normal distribution. That's why normal distribution is important in statistics. I want you to understand this stuff. Then it's going to be easy. A little more left, but it is very important and interesting thing, especially this one, test the statistic. Okay? Okay. Thank you. This is it today. Bye now.